In this video, let's take a look at how a website like YouTube itself works. Now, a lot of us have always, like at some point you would have thought about, I would create my own website, my own thing, where maybe I can add some videos, some content. But when you think about adding videos, you most likely think about embedding videos, right? From YouTube or some other platform. But how does a platform like YouTube really work? You see, there is so much content on YouTube in general that you can't just create a platform like this unless you have optimized a lot of things. So in this video, my motive would be that we discover a few things about YouTube, we understand normal standard of streaming, how it works and how YouTube differs, and we take a look at some of the interesting bits. So let's start. So I'm gonna keep my own videos for the sake of, not having copyright or some sort of issue like that on the video itself. So let's try to take a look at this video which I have, right? I'll just inspect element, and by the way, like before we start, just a quick disclaimer, this is not teaching you in any way to download YouTube videos or in download any sort of other videos. It's purely from an educational perspective. If you have wondered about the technical use cases of YouTube, then it makes sense. Don't try to reverse engineer or create some sort of downloader or something, because as far as I know, that's not in favor of YouTube's terms. So anyway, I have my ad blocker on here and I'm also in incognito, so I will not be loading ads obviously on this. So I think these are the two calls which are going are for ads and for logging. So if I clear my log and if I shift my filter to all over here, and if I click on this, you see that something happens, right? Two things happen. The first one is that we get these bunch of requests, right? Which are image requests over here. So you see this is like sort of a sprite sheet. So what we call this, if you don't know about this is called as a sprite sheet. So what YouTube has done maybe is that they have created like a sprite sheet for, I don't think this is like every second or something, but maybe like every 2 seconds or 5 seconds. So when you hover over this video, I don't know why it's not working right now, but it generally works. So when you hover over this, for example, over here, when I'm hovering over this video, you can see my screen, like a little bit of screen. So over here, if I clear this and if I start hovering over this, you can see that I'm trying to make a lot of requests now, but there are not that many requests, right? You can see like I'm trying to load every single frame over here, but it's not a lot of requests, right? You can see like I'm changing this very quickly, but I'm not loading as many images. The reason for this is that if you open this URL over here, you can see that YouTube already created a sprite sheet. So it knows like internally that if I am on this second, show this image, if I'm on that second, show that image, and so on. Sprite sheet is very commonly used in games. So when you use games, when you build games, program games, you would not just ship individual assets, small assets as a single image. You just ship a huge file, right? And then based on the position of the image, you can just extract out one specific image from that big image. Now, second thing, this is like not the part of the video playback, but if you look at something around this, like once you have loaded the images, then YouTube gets a stats watch time thing where it's probably just a get call, so it doesn't has anything. So it's just sort of like posting some sort of analytical data. Then you have this video playback, which is the actual thing, right? This is the actual bit, which is the playback video. If I go ahead and take a look at this, I'm not able to see the response, but if I open this in a new tab, you can see I'm almost like sort of starts to download a specific video. It's a 35 byte thing, right? So it's not like really a video itself, but it's something. So if I clear this again and if I play back this and if I load on a part which has not been buffered, you would be able to see that I get this part again, and then if I keep on loading this, you get to see that I keep on getting these small parts every single time, right? So let's take a look at in depth into what's happening over here. First things first, you see the content type of this part is application and then vnd.yt-ump, which is not a standard application type, right? It's not a chunk of video which is like popularly known in HLS, or it's not an MP4, it's not any of that. So first of all, what we have to realize that it's some sort of custom format which YouTube uses, right? It's not HLS streaming. It doesn't seem like HLS, because if I reload this page, for example, and if I try to pause this video and if I try to search for some manifest file or something around that, you see that we don't have any manifest file or anything. So it's not an HLS based streaming. And if you want to learn more about HLS and how the streaming sort of works, I think another video, I'll link it down someplace. But let's take a look at how this part comes to be, how YouTube knows that it has to go to googlevideo.com, for example. So in this specific case, if I go to the page source and if I enable line wrap, you would see that inside the source code itself, there is some data which is server rendered by Google, right? Which is this, particularly this JSON, this YT initial player response, right? So this thing is server rendered by Google itself. There is no backend call or anything involved. And it's doing this for every single video, right? Which you are playing on YouTube. So if I open this context a little bit, you will see that we get a lot of information inside this, from video details to thumbnails. I have like all the thumbnails and resolution. So I have a lot of data inside this single object. And inside this streaming data, which is one of the keys now, you see that there is an array of 25 elements, right? So this is interesting. If you take a look inside this, you can now see the actual MIME type, which is the actual video which is getting served, right? So it has this video MP4, which has a AVC1 codec in 1080p. And you can see this is the initial URL, right? This is the first set of URL, which I'm assuming is available. So if I copy this and if I try to open this, I'm sure it will not just work right out of the box, right? So you can just make it work, but this must be the initial URL which YouTube is giving the browser for the playback. You have the FPS, you have the content length, you have the approx duration, which is like close to 10 minutes. So a lot of data is over here, right? And you can see the codecs are also changing a bit. So we have this format video MP4, and then codec over here is AV01. Then we have a video WebM format and a codec of VP9. And I think that YouTube plays VP9 itself when it gets a chance in a browser, because VP9 is a very nice, it produces like a very compressed video file, right? Without much loss of quality, but it's quality 144p, right? So it makes a lot of more sense because YouTube is delivering you the smallest size possible for the smallest resolution. In fact, it also has a lot of data like loudness in decibels. For this segment, most likely, I don't know. This is for audio, right? So for audio, it has like loudness in decibels. I don't know if I sound -5 in decibel. I don't know like if that is true. But anyway, this over here, the first call which we made is coming from the JSON which we have in server rendered format from YouTube. And this first call which you see is also a post call, right? If I try to copy this request, copy as fetch, and if I try to clear this and make this request like this, okay, so it also has some binary sort of data in body, right? So it's making this post request, but it has this weird data inside its body format, right? Now, of course, like YouTube has always been, figuring out how do we get ahead of people who are downloading our videos, who are doing like, bypassing ads and so on. Chrome has been like working on Manifest v3. So a lot of things are there, but the basic idea is that all of these things lead to an abstraction which can be broken. But the core idea is that YouTube downloads your video in a small chunk by chunk manner, right? It doesn't download the whole thing at one go. So if I clear this again, and if I click on a part which has not loaded, you will see these two requests which are made, and these requests are also like sort of made by service worker, right? So YouTube like sort of is hiding a lot of things within its service worker and its architecture. So let's just try to simplify this a bit and let's just shift to a phone. Let's just say I am on an iPhone 12 Pro, right? Where YouTube would be forced to fall back to an approach where it can't use these fancy things, I hope. Okay, so now I'm on phone, and now if we take a look at what YouTube tries to do now, then you will see is that if I clear this and if I play this again, and if I click on here, over here, let's say if I drag this somewhere here, you can see now we are also getting sort of similar request, but not in service worker, right? So at least we can see the size and all, but the response data is still not available. So if we look into this, I mean, this is mostly cryptic. YouTube has changed a lot of things. I think last time I remember it was not this complex, but if we look into this and if we just add a debugger point just to see like what YouTube does, let me just start another video, maybe just unpause it for now. And now, so let's see. So over here, you can see this is how YouTube constructs a request for every single part, right? And if you hover over this, you can see the actual URL, which it is using to retrieve the video part, and the body also, which it assigns over here. So let's go a little bit one step back into this, and we can see that A over here, you see this argument A is the actual body, which becomes the real body, right? It's overriding it, but it's the actual real body. So let's keep going back. Let's say if I add the next debugger endpoint over here. Okay, so we see this new URL, which is there. So this request has not been made yet, it's about to be made over here. So once I go into the start method, now you see that we construct this new request and then we fetch it. So what if we try to fetch this right now? So what if I say something like const result await fetch a, right? And of course you can't use await in a debugger. So now I have result, and if I play this, and if I just remove the debugger now, and if I have res, so if I have res2 as await res, so you see over here in res2 also, if I try to convert into text, obviously it's not text, but you see this is the sort of binary data which is inside this video, this 800 KB thing, right, which is there. So if I try to convert this into an array buffer, I mean, I've already read the body, but if you try to do that, you would be able to actually get the video content. And then based on like whatever codec it is, whatever the thing it is, video, YouTube playbacks this video. So this is like the actual content which is getting downloaded on every one of these requests. Now, if we take a look at something which is live, where things get interesting, right? Because now you need to have some sort of manifest file or something for playback. If I open, let's say this news channel, for example, and if I take a look at what's happening, what's going on over here. So over here also you can see like it's in the same way, it's in the same format that you have these video playback URLs, which are, which are including this data of the video file itself. But you see that what YouTube is not doing over here, something which we can just make out of by seeing the platform itself, is that YouTube is not requesting for a manifest file, right? So this heartbeat also doesn't look like a manifest file. It's just a normal sort of thing, right? So all you see is these video playback requests. So the architecture which YouTube has not only includes, most likely, which I think not only includes the video content in the single request, but it also includes information about the next packet or the next thing, especially in the case of live, because in this case, you can't do much unless you ping manifest. So generally how playbacks usually work is that you have an HLS playback, let's say you have an HLS video. So what you will do is that you will convert your video into very small files, right? 1.ts, 2.ts, whether you are doing it live or whether you are doing it like, in a recorded format. And then what your client, which is your browser, which is your user, it will do is that it will keep on downloading these individual bits, right, one by one. But in case of live, for example, it will also keep on pinging a single file, which is the manifest file, which in turn includes the data of all these files. It doesn't include the actual data, but it includes like, right now we have 4.ts. Now we have 5.ts and so on. So your user will keep on asking manifest. Once manifest says that, okay, 5.ts is available, your user will go ahead and download that file and then it will play it back. YouTube, on the other hand, because you can see that there is no manifest call going on over here. In case of a live stream also, you can see this is live. So YouTube possibly can't have like information about this. They download this manifest data within the video playback data itself, just to optimize the stack, I'm assuming, which is interesting. And YouTube does not use any standard playback technique also. Nothing which you're seeing over here is standard, right? This is all non-standard. Google Video Server, I'm assuming this GVS stands for that. You can see some bandwidth headers. You can see some optimizations for the front-end player to see like what sort of resolution or thing it should pick, right? And if I, for example, if I go to quality tab and if I change this to 144p, you can see like suddenly it's able to switch from within this URL, right? So it has this one playback URL, then it has a bunch of parameters which you can take a look at. And then every single packet has some sort of information for the next packet. Right, so you can download this packet, but you will only get that playback, or you might not be even able to play this, right? Because it might be encoded in such a way. Now, of course, you can jump into this and like really see what YouTube does after the playback, starts, and you can like play around, reverse engineer this a little bit. But I mean, like very simply speaking, this is how YouTube in general works, right? So the downloaders which you're seeing today, I'm assuming they are doing a lot of work, because at least 5 to 10 years back, when YouTube was there, the playback used to be very simple, very, very simple. It used to be just a single file. And if you're able to like open that file, you would be able to download it. I have been there, like I have seen that time where it was just a single file, or like it was slightly complex. I don't exactly remember, but it was relatively simple to play back the YouTube video without like actually, decoding all of this and all of that. But now on, at least on the front end side, it looks like they have added like a bunch of things, but of course, like still YouTube videos are downloadable. So yeah, that's pretty much it for this video. Hopefully you learned something new. Do let me know in the comments what do you think about this, and try to reverse engineer this a bit, obviously just for educational purposes. See if you learn something new. That's all for this one, and I will see you in the next video really soon.